Assalamualaikum warahmatullahi wabarakatuh to Madam and all my beloved friends. Today we are gonna present to you about application of differentiation MAT183 Calculus 1. Without further ado, let's get started. So, this is my team. First, Muhammad Afnan bin Azmi, his matrix number is 2021826158. And myself, Wan Nur Asyikin binti Wan Ahmad Izani, my matrix number is 2022696432. And we are from CS143 and CS111. Our course group is CDCS 1112C.
First, what is differentiation? Basically, the differentiation is a concern about how one quantity changes in relation to another quantity. It can be approached in two different ways. There are interpretation of tangent line and rate of change. We can assess how quickly or slowly a specific quantity changes by looking at the second quantity's rate of change. The uses of differentiation, one of it is it able to measure temperature variation. Second, calculate the profit and loss in business using graph. Third, discover the aqueous magnitude range. And the last one, measure the distance of speed traveled.
Problem statement.
Okay. For situation 1, a spherical soap bubble is expanding so that its radius is increasing at the rate of 0.02 cm per second. At what rate is the surface area is increasing when its radius is 5 cm?
For the second situation, it sounds like this. A stone is dropped into a quiet pond and the waves moves in circle. If the radius of the circular wave increases at the rate of 8 cm per second, find the rate of increase in its area at the instant when its radius is 6 cm.
Problem solution.
Solution for situation 1 is, imagine we have a spherical soap bubble and we know that its radius is increasing at a constant rate of 0.02 cm per second. Our goal is to find out how quickly the surface area of the bubble is increasing when the radius reaches 5 cm. Okay. To solve this problem, we will need a few key equations. The first equation we will use relates the surface area of a sphere to its radius. The formula for the surface area of a sphere is given by, which is 4 pi r square. Since we want to find how the surface area changes with time, we will differentiate this equation with respect to time. Okay. Using the chain rule from calculus, we can break down the differentiation of this equation further. The derivative of the surface area with respect to time is equal to 8 pi r dr dt. Now that we have the general equation, let's substitute the given values into the equation. The radius is 5 cm and the rate of change of the radius dr dt is 0.02 cm per second. By simplifying the equation, we find that ds per dt is equal to 2.512 cm square per second.
So, this is our solution for the second situation. Based on our equation, the concept that we can get is area of circle is given by pi times r square, where r is the radius of the circle. Second, if y equal to fs, then dy over ds denotes the rate of change of y with respect to s. Its value at s equals to a is denoted by dy over ds as equal to a. Third, decreasing rate is represented by negative sign, whereas increasing rate is represented by positive sign. This question we can use chain rule. Let y equals to Fv be a differentiable function of V and V equals to Gs be a differentiable function of S, then it can be like dy over ds equals to dy over dv times dv over ds. So for this question, the first we can do is when the stone is dropped in the quiet pond, the corresponding waves generated move in circular form, given dr over dt equals to 8 centimeter per second. So here we have to find the rate of increase in the area of the circular wave formed at the instant when the radius r equals to 6 centimeter. As we know that area of circle is given by pi times r square, where is the radius of the circle. Let a equals to pi times r square. As we know that if y equals to fs, then dy over dx denotes the rate of change of y with respect to s. So, by differentiate a with respect to t, we get dA over dt equals to dA over dr times dr over dt. The next step is dA over dr equals to d bracket in bracket pi times r square over dr equals to 2 pi r. By, sub, by substitute dA over dr in dA over dt, we get dA over dr equals to 2 pi r times dr over dt. By substitute r equals to 6 centimeter and dr over dt equals to 8 centimeter per second. In the above equation, we get dA over dt equals to 2 pi times 6 times 8 equals to 69 pi centimeter square per second. Hence, the rate of increase in the area of circular waves formed at the instant when its radius is 6 cm is 69 pi centimeter square per second.
For the conclusion, based on our research, we find many things that can be solved by using application of differentiation. For example, we can measure temperature variation, calculate the profit and loss in business using graph, and tell us which speed we are driving and help us predict fluctuation on the stock market. And we take a spherical soap bubble and a stone which is being dropped into the pond as our problem to be solved. From our problem, we can determine that the surface area for both situations is 2.512 centimeters square per second and 69 pi centimeters square per second. That's all from us. Thank you.